Good afternoon, dear colleagues, respected participants of the 14th International Conference on Mathematics, Science and Technology Education. We are pleased to welcome you to the session Technology Education, Mathematics and Mathematics Education, Physics and Physics Education. At this difficult time, every Ukrainian is fighting on his front. Our front is scientific. So, glory to Ukraine. And Svetlana Leonidovna, do you want to see?
Yes, I'm glad to see our colleagues and good luck for a start.
Okay. And we are beginning. So invite the first speakers, the team of scientists from the Ateneo de Manila University, the Philippines.
Hello and good day. I'm Plata here to present our study for the application of image processing programs in color analysis of wood photodegradation. With special thanks to my co-author and advisor, Dr. Ramon M. de los Santos, for their guidance. The presentation will have the following structure. Number one, there will be a segment for the background on UV radiation and how it affects wood. This is followed by the presentation of the research questions. Then there will be a brief overview of the methodology in using image processing programs. Afterwards, an overview into the most important results. And finally, key takeaways will be articulated in the conclusion and recommendations. First of all, we look into the significance of this study. Our research demonstrates the significance of improvising methods and setups in STEM education to analyze various physical phenomena amidst the COVID-19 pandemic. In the literature, most photodegradation studies process their samples through photoirradiation in the laboratory. However, that is not always available for students depending on the circumstances. Additionally, this study will look to investigate the photodegradation effect onto wood samples that have limited known results to our best knowledge. As mentioned, this will be done through color change analysis and FTIR, ATR spectroscopy. Onto the background.
Irina Sergeyevna, what do you have a problem?
Шановні колеги, хто забрав роль організатора?
Давайте не так. Роль організатора. Спробуйте ще раз запустити.
Thus provides the opportunity for oxidation in the wood species. As a result, the lignin is expected to degrade and other components are formed, such as carbonyls and carboxyls. Through our significance and background of study, we're able to form our research questions. Particularly, we wish to investigate how our chosen processing programs can verify or suggest photodegradation. Most studies investigate the color changes directly with a spectrophotometer, but we investigate alternative methods and learn if the same effects may be observed in such a way. Additionally, we wish to investigate changes in the appearance of our chosen wood sample, tangile. Being a service phenomenon, photodegradation is expected to change the appearance of wood as observed in the literature. We aim to observe similar changes should the study support other known and accepted observations from other wood species. Upon investigating any changes in appearance, we wish to confirm compositional changes in the wood polymer structure. Should the study support other accepted observations, then the lignin should decompose and decrease in its content. While the more detailed process will be found in our paper, for now, here is our overview for the methodology. For UV light exposure, a germicidal lamp was used and was enclosed in a wooden box, with the wood samples propped up on the side facing the lamp, which was attached to a trolley. Samples were exposed at hourly intervals up to 3 hours. For safety reasons, it is strongly recommended that the UV tests are done away from any human contact or other parts that may be affected during testing. Holes were made on the sides of the box to expel any ozone that may have formed during testing. For picture taking, the top of the box was removed. On the right is the image capture setup for the samples before and after exposure. The camera distance was kept constant with a tripod, and the samples were placed flat on the table and on top of a sheet of paper to give the samples the same white background. Pictures were also taken at the same time for consistency. After pictures were taken, the photos were processed in Image J. The original photo was split into colored channels through the process mentioned in the slide. There were 3 color channels formed for the same original image, which was used to get the color images later on. It was ensured that there was enough screen space to properly organize the 3 color channels so that the data collection was smooth and more efficient. The process on this slide further elaborates on the steps taken to get the color measurements of the image that was split into colored channels. It is necessary to set a scale so that the measurements return in the preferred units instead of pixels. The scale for this study is found on the slide. A rectangle near the center of the color channel was created for the color measurements. Using the measure function, the color measurement was taken as an average. An example of this is encircled on the diagram to the right for the red color channel of the Tangile wood. To the right, it is also represented by the minimum and maximum values measured along the red scale. This was repeated for the green and blue color channels, with their results recorded appropriately. The more detailed process is in the paper, especially on how to automate this process should there be more samples later on. It is necessary to convert the values measured in Image J, which are in RGB coordinates, into CIE lab coordinates, which is the set of coordinates more commonly found in photodegradation studies of wood. Additionally, L star, A star, and B star coordinates provide more information towards the color changes, such as change in lightness in the L star scale, change in redness in the A star scale, and change in yellowness in the B star scale. With the RGB coordinates, the values were converted using the Python color math library. By importing the sRGB color, LAB color, and convert color libraries, the values are converted through one function encircled as divided by 255 in order to scale the values between 0 and 1. Moreover, it is necessary to set constants for the observer angle and target illuminant, depending on the scale that was used for the experiment. After the methodology, we are able to present our most important results. For qualitative observations on our chosen Tangile wood, it is possible to observe slight color change from unexposed to exposed samples in the diagram on the left. The change may be minimal through the eyes, but nevertheless, the darkening is still there and visible. Since qualitative observations are arguable, it is necessary to support these changes quantitatively, using the equation for total color change, which is found by taking the square roots of the sum of the changes in color along the L star, A star, and B star coordinates. The amount of color change is calculated to a value of 4.29, which, according to a study by KRYVYI et al., equates qualitatively to appreciable color change. Therefore, there was enough color change to suggest the photodegradation effect on our Tangile wood sample. We support this information by taking the absorbance ratios and using the spectral difference for unexposed and exposed samples of Tangile wood. The decrease in ratio for the 1340 over 1320 wave number suggests an increase in cellulose 1 content for our sample. This is supported by the positive values in the different spectra at the 1509 and 2300 to 1900 per centimeter wave number. We directly associate to lining bonds according to Derkach et al. The positive value means that there is less detection at the exposed samples than the unexposed, indicating the degradation of lignin as a result of UV exposure. From this set of data, we can conclude that image processing software for color analysis was able to suggest wood photodegradation as an alternative method from spectral photometers. Additionally, our chosen sample, Tangile wood, was able to illustrate appreciable color change, and that information is supported with the compositional changes in the Tangile wood polymers as a result of the photodegradation effect. For recommendations and further research, we suggest to expand the exposure time up to 12 hours to maintain consistency with accepted literature and to ensure that there are no anomalies in photodegradation after 3 hours. Additionally, whenever possible, it is recommended that results are reproduced for a laboratory spectral photometer for more controlled results in an ideal setup. Here are the references that were highlighted in this presentation. Thank you for listening. We are now open to any questions or comments that you may have. Thank you very much.
Thank you.
Are there any questions, colleagues? Please, you can ask you, Gabriela Plata.
Yes, I have a question. Indeed, quarantine has actually mass-used technology that used to be used by the few. And you, in your research, are conducting complex experiments using tools that are available to almost everyone. How do you think these tools can be used in school education?
Yes, so first of all, thank you for the question. Especially for school education, I think it's very important to expose the students first to these techniques, even if it might not be the complex machines or the complex spectral photometers yet, because we want to introduce them to the idea that of how the general steps of how it works. For example, how do you process images and get results from that? So I think it's really more about the exposing the process first, and then so that when they get to handling more the complex machines, then they already know the general process. So now they can focus more on the intricate details, so the fine tuning of the machine, so that it will come maybe a bit faster to them, the information, and then they can do more results. So I hope that answers your question. Thank you.
Thank you for your answer.
Okay.
Dear colleagues, in our chat, Yana Shuhailo wrote a very interesting presentation. Yes.
Well, thank you, Yana.
I agree.
Yes, thank you. Thank you, everyone. And if I may add, so the reason why we actually started this experiment is because we want to offer an alternative method to observe photo degradation in general without necessarily requiring sophisticated instruments. And we can do this at home. And my student was able to do this on a work from home basis, a purely work from home experiment. And we believe that we were successful in carrying out this particular experiment, and we're able to show that photo degradation can also be observed using a home-based setup. Thank you.
I understand. Thank you.
Okay, and we are going to next presentation, and the next team from Ukraine, it's Yana Shuhailo and Tatiana Derkach, and their paper, Incorporation of Upcycling Technique into Technology Education.
Authors are Yana Shuhailo, Tatiana Derkach, Anastasia Shpetna, and Tamara Ustenko, representatives of Kyiv National University of Technologies and Design and International Sustainability Academy. The global fashion industry annually produces 92 million tons of waste. One of the critical problems nowadays is optimal disposal and reuse of textile waste. The role of higher education in promoting the ideas of sustainable development, circular economy, and the formation of ethical standards for the reuse of products is defining. It consists both in the introduction of new organizational forms that enhance the effectiveness of educational activities and in bringing the content of educational programs to the requirements of professional activity in terms of sustainable development. Analysis of the educational programs in professional education in various specialties showed that the competencies of graduates required for sustainable production are not provided at the level of proved standards of higher education in Ukraine. As a result, students have specific gaps in knowledge. Students should be able to use technologies aimed at waste administration, among the list of which are technologies of recycling and upcycling. It is necessary to introduce skills of textile waste administration, both at all stages of production and the stage of use and subsequent disposal of used products into the educational process of technology education, to train specialists capable of working in a sustainable environment according to modern circular economy models. The research aims to formulate existing problems and explore ways to form the necessary competencies of future technologists and designers of the light industry, which will provide knowledge and skills on waste disposal of fashion industry products and work in the business environment of circular economy models. People buy clothes to wear for a short period. Then these clothes quickly turn into textile waste. Textile waste can be classified in three categories. First is residues of many manufacturing processes in the textile and garment industry. The second type is called textile waste after consumption. And the third category is post-industrial textile waste, formed during production processes as byproducts. The amount of waste after consumption is excessive and constantly increasing. This problem is unlikely to be solved entirely as long as designers in developing their products will not embed the possibility of their reuse, style change, design change, and build the option of reproduction in the design of all products. Recycling is a method of reusing or recycling used clothing and waste materials in the production process. Recycling can go one of two ways. The first way is downcycling, when receiving a substance of lower quality. And this way, used clothes can be processed into non-woven textiles, building insulation, rags, or carpeting. The second way is upcycling. It can be illustrated as upward processing. Upcycling should be considered primarily as a process of reconstruction. It creates an original waste product that usually has a higher retail cost than traditional recyclables. Creating business models in the fashion industry based on circular economy principles has at least three different dimensions. The first is related to personal characteristics and psychological motivation for the use of upcycling technologies. The second dimension is the availability and development of individual skills, knowledge, and skills in upcycling. And the third level is the knowledge and skills needed to apply upcycling technologies in the business environment. Combination model of theory of interpersonal behavior and theory of planned behavior is presented on the slide. It identifies three main factors that shape the probability of behavior. They are behavior intention, the strengths of habits, and the presence or absence of facilitating conditions. Habits are measured by the number of attempts to act. Facilitating conditions are, for example, tools, products, or materials. Indicator of frequency of upcycling is how often the person practices upcycling. The benefits can be economical, environmental, psychological, and social cultural. Behavior intentions are formed under attitude, social factors, and perceived behavior control. Attitude is formed by perceived consequences and the value of the consequences. Social factors include three elements: subjective norms, personal norms, and role beliefs. Subjective norms are the belief that a particular behavior is correct, appropriate, or desirable. Roles are sets of behaviors considered acceptable to those who hold certain position. For example, parents, leaders. Personal norms are person's ideas about oneself, self-concept. A survey of future technologists and designers of the light industry was performed to determine the probable behavior in upcycling and the main factors that shape this behavior. 95 students took part in it. Questions helped to assess students' attitudes, subjective norms, personal norms, role beliefs, perceived behavior control, intentions, perceived facilitating conditions, perceived benefits, and match with the frequency of upcycling behavior. In the answers was used 7 points Likert scale. The sample of respondents contains two branches that partially overlap. The branch that accumulates respondents with less upcycling practice, which can be conditionally called a group of negative attitudes, is more numerous. It includes 41 respondents who on average practice upcycling about once a year. The group of active upcyclers includes 40 people with an upcycling frequency of once every 1-3 months. That's a group of positive attitude. The remaining 14 people in their answers indicate the frequency of upcycling about 6 months. That's a group with unformed attitude. The average survey results for the three groups are shown on this slide. The most influential factors are attitude, perceived behavior control, and intentions. On the second figure are compared the results of strong upcyclers with the green color. That's respondents who practice upcycling weekly or even more often, and the other students, the lines with a white color. To the group of strong upcyclers can be included only 5 people out of 95 surveyed students. That is about 5%. Strong upcyclers are aware of benefits of upcycling, while the vast majority are not. There are two possible reasons for contradictions between a positive attitude and lack of awareness of benefits. First is insufficient attention, unformed infrastructure and legislation on waste recycling in Ukrainian society. People who do not practice upcycling often and regularly do not feel the public need and are not aware of the potential benefits of such activities. And second is education gap. The list of competencies that future garment technologists and designers must master does not involve the development of knowledge and skills needed to understand the importance and mastery of upcycling techniques. Due to the specifics of clothing products, upcycling in design and production is mainly applied to unique products or for minimal series by tailors or small companies. But the aim is to shift gradually from the individual upcycling to the development of forms of small and medium size. It becomes apparent that need to create different design processes and methods for recycling and reuse of waste. The integration of waste and recycling into the design process requires a change of thinking and approach. The design process depends on the type of waste collected and therefore requires constant adaptation and experimentation. And also, it is essential to develop students' creativity. Stakeholders think that creativity is one of the most important and necessary competences. On the next slides, the examples of the author's experience of implementing new methods and tasks to form creativity and organizing sustainable production using upcycling techniques in students majoring in professional education at KRYVYI are presented. Here we can see the name of the discipline, for example, methods of professional training, types of students' activity, description, and purpose. The next discipline, that's fundamentals of engineering and pedagogical creativity. Also, the changes were made in the disciplines fundamentals of clothing design and creative learning technologies. On this slide is presented the example of the startup project, Designer Products from Textile Waste, Creation and Sale, designed by Tamara Ustenko. The initial goal was to access the possibility of creating a company that focuses on the processing of used clothing and textiles to develop new projects. The next slides, they present their examples of students' work. For example, here you can see a patchwork technique used to create a pillowcase from the textile waste. That's also a patchwork technique to use a bag from a textile waste. And here is presented an upcycling process of the denim jacket, old-fashioned. Through a survey according to the combined model of theory of interpersonal behavior and theory of planned behavior, the personal motives of students of technology and designers regarding their participation in activities related to the processing of raw material are determined. According to the frequency of application of upcycling techniques, all respondents have divided approximately in half. The division is between those who participate them regularly, that's once per 1-3 months or more often, and those who use them infrequently, once a year or less. About 15% of respondents did not decide on their preferences. Regarding on the prospects of introducing upcycling technologies in future professional activities, there are problems at 3 levels: personal perception of upcycling, the formation of relevant skills and knowledge, and lack of experience in scaling personal expertise to the level of business startups. Factors influencing the commitment to use of upcycling are identified. The most influential is one's attitude, control of behavior, and formed intentions. These factors shape the behavior of all defined groups, regardless of the frequency of application of upcycling techniques. The influence of social factors, perceived habits, and facilitation conditions is more moderate. It affects the behavior of people who are more prone to upcycling and has almost no effect on indifferent people. The contradiction between the high level of attitude and low evaluation of students' perceived benefits is revealed. Most students have a poor understanding of the benefits of upcycling. People who, for personal reasons, do not practice upcycling often and regularly do not feel the public need it and are not aware of the potential benefits of such activities. An important reason for this attitude is the education gap. A lack of attention to the development of competence creativity presents in the current higher education standards in the relevant field of knowledge. Meanwhile, generating ideas is key to mastering upcycling technology by textile industry specialists. Examples of possible changes in the curricula of disciplines, methods of professional training, fundamentals of engineering and pedagogical creativity, fundamentals of clothing design, creative learning technologies, aimed at the formation of creativity, have already passed practical testing at KNUT. The main reasons that complicate the scaling of acquired skills and knowledge in developing business startups with upcycling are analyzed. An example of the developed startup project Designer Products from Textile Waste Creation and Sale is given. Thank you for attention.
Thank you for your presentation. And dear colleagues, are there any questions?
May I start from the question from the chat? What made the researchers focus on textile waste? Is fast fashion a major problem in Ukraine? Really, we have a big problem with fast fashion in Ukraine, and we really have the situation that it is one of the biggest polluters, and we have to move to the slow fashion. And also, one of the reasons is that Ukraine, because of economical factors, imports many tons of textile waste of second-hand clothes from other countries. And the amount of waste after consumption is increasing every year. And that is why it is so important to solve this problem. And that's one of the reasons why we focused on this problem of the textile waste after consumption.
Yes, thank you, Professor Hannah. Actually, we have the same problem here in the Philippines.
Thank you so much. I think that many countries have faced the same.
Okay, and I have questions too. The research states that students' knowledge and skills meet the requirements of linear economics, not circular. What is the difference between these models, and what are the ways to train students for professional activities in circular economy conditions?
Thank you so much for your question. If we are talking about linear economy, we very often use this model is about taking as resources as we want, take, make, and then waste. It ends with the waste production. And if we are talking about circular economy, we understand that nowadays, first of all, the other generations will also have to satisfy their own needs, and they will not have as many resources as it was before. That is why we have to make it like a circle. All the resources that were used during the production have then become the material. They can be biodegradable, they can return to the ground, to the soil, and a second way, we have to or upcycle them or to recycle. They have to become materials for the further production. And about the second part of the question, what should we do? First of all, we have to learn to train our students how to design, and from the very beginning, they should know that this for example, clothing then can be redesigned. This clothing can be recycled or upcycled. Also, it's very important if you're talking especially about upcycling to develop the creativity. Because if you want to upcycle something, first of all, you have to imagine what do you want to receive as a product. And also, it's more difficult. We have studied a lot of resources, and all the designers, all people working in this field, they tell about that it is a more challenging process when you work with recycled materials, or you have to upcycle some clothes or some material.
Okay, thank you for explained answer.
Thank you so much.
And
are there any questions, colleagues? Okay, then thank you, Jana, for your reports. It's very interesting.
Thank you so much.
It's a pleasure. Thank you. And we go to next report from Vladimir. They speak about improving the quality of mathematics educations of pupils. Okay, we can start.
Dear colleagues, let me introduce the results of research on the topic improving the quality of mathematical education of pupils, diagnostics and analytics. The authors of research are Lilia Grinevich, Lyudmila Kharuzha, and Vladimir Proshkin. We are the professors of Boris Grynchenko, Kyiv University, Ukraine. Mathematics can rightly be attributed to the key factors in the development of civilization. Technical progress, computer science, etc. have been developed on the basis of mathematics. Mathematical education in the system of general secondary education occupies one of the leading places, which is determined by its practical orientation, opportunities for human competence development. In recent years, our country has taken a number of initiatives aimed at improving school education in general and mathematics in particular. Among them are the concept of implementation of state policy in the field of reforming general secondary education for the period up to 2029 new Ukrainian school, the concept of development of science and mathematical education, STEM education, the announcement of the 2021 academic year as a year of mathematical education in Ukraine. Despite the above measures that are being implemented or have already been implemented in the educational process, the issue of the quality of mathematical training of school pupils remains extremely relevant. The outlined problem squares special significance for Kyiv educational institutions, which usually serve as a reference point for the function and development of the education system for other regions of our country. However, according to the preliminary results of the evaluation of the quality of education, the capital's general secondary education institutes have certain problems in the context of science and mathematical strain of pupils. They encourage the scientific community to modernize and update mathematical training in school in accordance with the leading ideas of the concept of a new Ukrainian school, which among the key competence necessary for successful self-realization in society defines mathematical competence. The purpose of the study is to analyze the results of pupils' diagnostics on the ability to apply mathematical acquired knowledge to solve practical problems and to develop the recommendations for improving the quality of mathematics education at school. The respondents of research were 15 years old pupils from school in Kyiv. In most countries, it's age when pupils graduate from general school faced with choose of profession and future life path in general. The study, which took place on September 29, 2021, involved 1,859 10th graders representing 292 Kyiv. They were asked to complete the task for the 8th grade of 4 levels of difficulty: beginner, intermediate, sufficient, and high. The mathematical tests were prepared by the staff of Ukrainian Center for Educational Quality Assessment. The test was prepared in accordance with the requirements of the International Program for Assessment of Student Achievements, PISA. The test consists of 10 tasks, which took 20 minutes. The semantic blocks of the test consisted of the following topics: numbers and expressions, equations and inequality, functions, triangles, circles, vectors, and coordinates. The study did not aim to find out how well pupils mastered the content of the school program. The ability to use the knowledge, skills, and abilities acquired as a school to overcome real life difficulties and challenges were assessed. This ability is a clear understanding of the role of natural and mathematical knowledge in the modern world, the ability to explain natural and scientific phenomena, draw sound conclusions about them, understand the impact of science and technology on the material, intellectual, and cultural environment. The following results of solving mathematics problems were obtained. Pupils gave the correct answer for 49.5% of tasks. Pupils gave the wrong answer for 30.4% of tasks, and pupils did not provide answer for 20.1% of tasks. Now let's analyze the success of mathematical tasks. The study found that the best people solved problems of the following topics: numbers and expressions, numerical sets, functions, formula, coordinates, and vectors, coordinates of the points. The range of the correct answers ranged from 84.2 to 90.4%. Let's analyze one of these tasks. You can see this task on your screen. Task number 1. What is the number of participants in a video conference? There were 4 variants of answer: A, B, C. Statistics show that 8.4% of respondents did not understand the condition of the task and believe that the number of participants in the video conference could be non-integer or negative. To determine the correct answer, it was necessary to find out that the number 160 is not a square of a natural number, and that the number 200 is not divisible by 3. So, according to the results of the study, improving the mathematical training of pupils in Kyiv is a complex and multi-vector process that can be implemented in the synergy of its various spectrums. Here are methodological recommendations for improving the quality of mathematics education of pupils in the context of the reform of the new Ukrainian school. Our first recommendation is about increasing the attention of teachers to the study of those learning topics that cause the greatest difficulties for pupils in the testing process. These topics you can see on the screen now. The second one, in accordance with the requirements of the state standard of basic secondary education, teachers of natural sciences and mathematics of 5-9 classes focus on the competence potential of mathematics and natural sciences, focus on real practical life problems and the relevant to people and motivate them to learn. Also take attention to the problem of introduction, the interactive learning technologies, strength team learning activities, use of digital tools for demonstration, simulation of experiments to promote group works, electives to increase the level of interest of pupils in the study of natural sciences and mathematics. Screen you can see the conclusions of our research. Also, I would add that the methodological support of the implementation of recommendations requires additional study. And we also invite to read the full text of our research. You may scan the QR code for it or use this link. Thank you for your attention.
Okay, thank you, Volodymyr. Dear colleagues, dear participants, have you any question? Okay, it was a very interesting report, and I have some question. Okay, did you use the only mathematics class, or maybe you used the integrated course? Or only mathematics for this task?
Dear colleagues, I'm glad to see you. I don't understand this question. You mean class like physics and mathematics or different classes? Okay, so we used different classes. There were classes from different region of Kyiv, from different level, and different kind. For example, from humanities or special physics and mathematics, or different kind of schools we used. Because there were mostly 300 schools in Kyiv.
Okay, I understand you, because there are many tasks of mathematics for the geography, biology, chemistry. I say about this. Okay, there are some questions in the chat. May I ask you what made the research focus on the test WASTED? East-West fashion major problems in Ukraine?
No, that was a question for the
sorry.
previous. May I ask another one? Also,
yes.
one more question. I understand that it's so difficult to make any prognosis, but as we see, the results are not very good of our pupils. What do you think? How fast can we make these changes and improve the situation with the knowledge of our pupils? I mean, in mathematics.
It's a rather difficult question, because we know that the problem of mathematical and science education in our country has unfortunately a rather long story, not very successful. But we think now, when we have evolved with Russia, nevertheless, in this time, we need to plan how to change the main ideas to teach of science and mathematics education, because one of the most important problem now. There are a lot of pupils and teachers are abroad in our country, and we need to think how to increase the level of our education, and they have an opportunity to return to Ukraine after our victory.
Thank you so much for your answer. Really, we really hope so that our pupils will return back home, and also hope that the situation with mathematics will improve soon, because as they have this test and they have to pass it. Thank you.
Thank you for your question.
Yes, mathematics, education of mathematics is very important today, but not all children understand that. Okay, thank you.
Thank you.
Are there any questions? Maybe. Okay, thank you, Volodymyr. And we start some report about STEM education, and next report is, I'm sorry, Natalia Kaidan, training of practice teacher for the application of STEM education.
Report on the topic training of practicing teachers for the application of STEM education. The modern informational society poses new challenges to the education system, and one of the ways to solve them is STEM education, which has become one of the popular learning trends. The development of STEM education is recognized as a priority both in the world and at the state level. The government of Ukraine has adopted the concept for the development of natural and mathematical education and developed an action plan for the implementation of the concept for the development of natural and mathematical education until 2027. The document defines a set of measures related to the formation and development of skills in research and engineering, invention, entrepreneurship, early professional self-determination, and readiness for informed choice of future profession, promotion of scientific, technical, and engineering professions, a dissemination of innovations in education. The implementation of measures is directly related to teacher training. It is a competence of teachers in the field of STEM education that is necessary condition for the larger scale implementation of STEM education. Researchers from a number of European research centers hold a similar view. In addition, the European Commission has adopted a digital education plan for 2021-2027. Among the planned actions is the involvement of women in STEM. According to the European Commission, such activities should increase the involvement of more participants in STEM education. Given that the majority of teachers are women, this activity is aimed at expanding the number of professionals involved in STEM education. Science, technology, engineering, and mathematics have already improved many aspects of life, such as health and well-being, infrastructure, sustainable energy production, agriculture, and more. In synergy with the social sciences and humanities, STEM has the potential to transform and improve people's lives while ensuring environmental sustainability and providing a basis for new approaches and solutions to current and future global problems. The question is to realize this potential through the training of specialists in this field. Training should begin in secondary school, and therefore an important step in this direction is the training of teachers who are able to convey the concept of STEM to students. University curricula for future teachers are adapted to the introduction of STEM education. The issue of retraining of practicing teachers, formation of their competencies in the implementation of STEM education, expansion of interdisciplinary learning skills, sustainable use of educational material based on a scientific approach, and combining theoretical material with its practical content remains unresolved. The process of teacher training in the context of the implementation of STEM education also has certain features. First, it is impossible to implement interdisciplinarity until the teacher acquires a thorough knowledge on the disciplines in which the integration takes place, So in the program of training teachers to use STEM technologies, basic disciplines must precede all others, and their mastery must be given enough time. Secondly, it is the need for practical experience, in particular in the implementation of project activities. This experience is gained by the teacher during a variety of exercises through independent work in laboratory and practical classes, in various types of repetition, as well as through the implementation of project activities during training, which encourages them to think about problems related to their learning. Third, it is very important to socialize and adapt the teacher in the professional circle, which will allow them to form an appropriate professional behavior, compare themselves to other teachers, as well as provide an incentive to continue learning. Fourth, the effectiveness of the teacher training process depends entirely on the level of formation of its value motivational sphere. Therefore, in the process of preparing teachers for the use of STEM technologies, it is necessary to create an appropriate motivational background, stimulating their psychological readiness to learn, as well as forming an active and positive attitude to technology in professional activities based on existing knowledge and experience. The process of preparing teachers for the application of STEM education is possible during self-educational activities and through activities during refresher courses. For this purpose, the Donbas State Pedagogical University has developed and is implementing a certificate program, Implementation of STEM Education in Educational Activities. The purpose of the certificate program is to form students' skills to implement STEM education in a scientifically sound and critical way, while use interdisciplinary interaction to introduce methods and means of STEM education in professional activity. The target audience of the program is future and practicing teachers of general and pre-higher education. The developed certificate program contains 5 content topics. The first is the proposed topics, STEM education, the state of implementation and prospects for development, aims to provide an overview of the STEM approach and current trends for the near and long term. Historical overview of STEM education, starting from the principle of clarity, allows to distinguish the genesis of STEM development, to trace the stages of formation and influences on STEM education from related and opposite approaches to learning. In addition to the lecture material for the course participants, an essay on what I know about STEM is offered. The second proposed topic of the certificate course, organization of STEM-oriented educational environment, forms the theoretical basis of the STEM approach to learning. Various aspects of the STEM learning environment, inherent tools, forms and methods of learning, etc. are considered. To consolidate the studied material, it is proposed to create a structure of STEM-oriented educational environment using mental maps. The third topic, use of STEM equipment in research projects, considered first of all a typical list of teaching aids and equipment for classrooms and STEM laboratories. Depending on the field of education, the list of equipment may differ significantly. The Ministry of Education and Science of Ukraine approved the standard list of teaching aids and equipment for classrooms and STEM laboratories. It determines the requirements for teaching aids and equipment, classrooms of biology, geography, mathematics, physics, chemistry, and STEM laboratories of state and municipal institutions of general, secondary, and vocational education. Since the main form of training in the certificate course is distance, the students get acquainted mostly with the emulation of equipment or with a visual representation of the stages of use of equipment. The practical part of the study of the topic is to choose from a typical list of teaching aids and equipment needed for the educational field taught by the students to a comparative analysis of its parameters and characteristics. The fourth topic of the program, network resources to support students' research activities, is devoted to the implementation of STEM education through network resources. This can be virtual labs, simulators, cloud storage services, and the analysis means of visualization of the received data and creation of infographics, etc. The practical part of the study of this topic involves the creation of an electronic educational resource designed to study the topic of knowledge of students taking the STEM approach into account. The fifth topic is aimed at studying the methodological aspects of the implementation of STEM education in the educational process. First of all, the peculiarities of the implementation of STEM education depending on the field of knowledge are considered. Each field of knowledge has its own characteristics related to the research activities and the contents with which the field and the specifics of the study of disciplines in this field of knowledge are built. The practical part of the study of the topic involves a detailed development of the lesson with the preparation of all necessary materials for it. The consideration of each topic is planned at levels corresponding to Bloom's taxonomy. Students learn basic knowledge of the topic connected with existing ones and try to apply them according to their field of knowledge. The result of the application, depending on the topic, may be new visual aids, including in digital form, the development of fragments of training sessions, tasks, including for self-educational activities that have practical significance, and so on. These stages allow us to form basic knowledge of the topic, but this will not be enough for us. Through group work, learners begin to test their own work on their colleagues. The results of the approbation, the conducted survey, the discussion in the groups of the performed on developments are used for carrying out the efficiency. The last step is to improve your own development and make it available to the public. The introduction of the principles of STEM education in the learning space contributes to the creation of a fundamentally new model of learning with new opportunities for teachers and students. Using an interdisciplinary approach, integration of school subjects, practical orientation, research and project activities during classes, focusing on the concept of STEM, we can build a modern, economically stable, smart and happy society with a high level of technology. The ongoing professional training of practitioners allows to adjust the educational trends, learning technologies and scientific approaches in teaching. The proposed certificate course for practicing teachers, which by the way can be taken by the future teachers, allows you to adjust the knowledge of STEM approach in teaching, expand knowledge of interdisciplinary interaction in teaching, improve scientific teaching of teaching materials, learn to form a scientific approach, and widely use project training. Thank you for attention.
Okay, thank you for your report. Yes, STEM education is very interesting and very popular in our task. And have you any questions?
May I ask,
Yes.
dear authors of the research, maybe I have missed something. Can you tell a little bit more about this certified program you have? Do people that have these certificates have some advantages when they want to get a new job at school and so on?
Can I answer this in Ukrainian? Yes? Стосовно сертифікації програми, так? Питання було.
Так.
Так, ми плануємо сертифікувати цю програму, але на даний час ми тільки почали використовувати, працюємо з цією програмою тільки перший рік, тому поки ще це в планах.
Щиро дякую. Thank you so much.
Thank you for your
Okay,
question.
okay, thank you for questions. Thank you for answer. Yes, certification program is very interesting
Yes.
idea, but realizing is have a problem, some problems. In our university, we have a special course in the curriculum, and we speak about for all students in the first course or second course. But certificate course is a future. And I have a question. One question. Okay, what about specialist? What about for students who can change this course? Only mathematics, physics, national science, or different?
Yes, знов таки українською. Так, у нас були вчителя математики, фізики, хімії. Хімії дуже мало, біології, і ми спробували між ними оцю взаємодію. Це було дуже цікаво.
А чи були такі філологічні спеціальності? Мене цікавить.
Так, один, але ми думаємо далі поширювати цю інформацію серед філологів, бо вони ще не дуже розуміють, як це можна. Ну, а може, просто інформації мало було рекламної. Але там дуже цікаві проекти є для філологів у нас.
Ну, ось саме про це я і теж у мене було питання, які рекомендації щодо реклами. І саме для філологів, тому що у нас в університеті це...
Speak English.
Okay, thank you. Okay. In our university, we stand on the robototechnics and used Legos, Ainstorm, Matata, and some others robot for languages, for study language.
Yes, I used Lego.
Yes. Lego and Mindstorm, Lego Education.
Yes, Mindstorm.
Okay, thank you, Natalia. Are there any questions?
Thank you for questions.
Okay, thank you. And next speaker, Olga Rovenska, about the learning-centered syllabus-based approach to engineering master students into research activity.
A learner-centered syllabus-based approach to engaging master students into research activity. This study presents a vision of a team of researchers on solving a problem of engaging future mathematics teachers into a research activity through implementing a person-centered approach to learning and teaching. The authors of the given article present a designed learner-centered syllabus of a training research workshop in mathematical analysis for master students majoring in mathematics at teacher training universities. According to a research by key European organizations stakeholders, success in developing students' scientific activity depends on the choice of the learning strategy. Being currently at the core of the educational process, student-centered learning and teaching make this process more varied and able to meet the increasing expectations from higher education stakeholders, which is emphasized in the standards and guidelines for quality assurance in the European higher education area. Thus, the issue of engaging future mathematics teachers into a research activity through person-centered approach is becoming relevant and timely. Defining the content of our study, we established that expanding the experience and fulfilling the potential has to take place in the environment, which has congruence, that is being genuine, open and transparent, acceptance, which includes respect and unconditioned positive attitude to the learning process. Empathic understanding, which means accepting other people's feelings and empathizing with them. The objective of the present study is to design a learner-centered syllabus for a training research workshop in mathematical analysis for master students majoring in mathematics at teacher training universities. To evaluate the designed learner-centered syllabus and confirm the efficiency of its introduction in order to engage master students into the course in mathematical analysis. The authors identified the rubrics and the structure of the learner-centered syllabus of the training research workshop in mathematical analysis for master students majoring in mathematics at teacher training universities. The content of the content-focused syllabus was analyzed and the rubrics of the syllabus were reviewed. The authors discussed the students' performance results, the description of the tasks and projects, as well as the description of the actions and strategies used by the teachers to facilitate the learning process and to promote an atmosphere of acceptance, support, respect and positive attitudes. The syllabi were evaluated, using the method designed to evaluate a learner-centered syllabus, rubric for determining degree of learning-centeredness in course syllabus. It allows to cover the whole spectrum of the attributes typical for the best student-centered teaching practices. The authors consider that a syllabus, designed in compliance with the learning-centered approach, is to showcase three key components: willingness to create a community, allocation of power and control in the community, clearly defined links between the learning performance and its assessment. With this in mind, the evaluation is done following three sets of criteria: community, power and control, assessment and evaluation, which encompass 12 subcategories. A 4-point scale from 1 to 4 points that accords with the increase in the level of student-centeredness is applied to assess the syllabus indicators in each subcategory. Growth in the rate of the learner-centered syllabus against the rates of the content-focused syllabus is shown in the figure. The results of evaluating the learner-centered syllabus concerning the increase in the degree of student-centeredness correlate with the positive growth in the rate of the number of attendees in the experimental groups. The authors present the learner-centered syllabus of the training research workshop in mathematical analysis, which is an elective course for master students, future mathematics teachers. The structure, the contents and the mode of presenting the learner-centered syllabus was designed in accordance with the person-centered approach to teaching and learning. The aforementioned factors led to creating the learning environment, which is defined by the emotional components of congruence, acceptance and empathic understanding. This syllabus has a positive impact on the degree of engagement of the students into the training research workshop in mathematical analysis, which allowed the authors thereof to prepare guidelines for developing learner-centered syllabi for research courses. Thank you for your attention. A model of learning the
Okay. It's a finished?
Yes, yes.
Yes, it's finished.
Okay, thank you for your report. Are there any questions? Okay, you speak about learning-centered syllabus, and I have some questions. Are the motives for influencing the choice of a discipline has been tested? Or only interest, only research?
Only interest.
Only interest, okay. And then we have also problems with some disciplines. What you advised your discipline? Тобто, як ви рекламували?
Ми рекламували через свій силабус дисципліну з математичного аналізу, зокрема семінар науково-дослідний з теорії наближень. Ну, він рекламувався саме через цей силабус.
Okay, where that was? In the site, in the library?
Yes, ми розміщували його на сайті, ми надавали студентам у попередніх семестрах, тобто через групи у Viber, ну, як ми робимо цю комунікацію з будь-яких питань, так? Тобто надавали через пошту, через групи в якихось месенджерах, ну і звісно, що було на сайті.
Okay, how many subject students have such таким чином?
Скільки студентів обрало
how many subject? Yes, maybe.
Там по різних роках були різні цифри, так, ми давали декілька років поспіль, і в першому році це було менше, а після цього 2-3 роки спостерігався приріст студентів, які обирали предмет. Ну, ми це пов'язуємо не тільки з тим, що ми надавали цей силабус, але і з тим, що студенти вже комунікували один з одним, так, хтось пройшов курс, і потім це вже передавалося наступним курсам, тобто і збільшення, ми думаємо, що і саме через це було.
Okay, I understand.
Because please, dear colleagues, speak English. Maybe your colleague may use English or other authors. Okay?
Okay. We will speak English.
Okay.
Thank you so much for your very interesting research. I think that obligatory we will read the paper, the whole paper, to understand what's the difference between syllabus that we are used to and this student-centered. Very interesting information.
To add something, if it's possible to add something. Can I add something? Because I am also too. Katerina Vlachenko, I am also too, and I would like to add something for the speech Olga Rovinska. To introduce our syllabus, I would like to say that we took attention to some syllabus quite renowned universities, something like Oxford, Stanford, and so on and so forth. To take this syllabus, we introduce our students with tradition and with the opportunity to use some information from this syllabus, that it's highly important for them to keep all paragraph of this syllabus, and when students, of course, understood how useful to keep this paragraph and information, they understood their goal, their task, and how they can get some marks, and how they can be scored, and this way they of course increased their motivation and their interest to this to mathematical analysis, because it's quite difficult subject in general, and of course it's quite difficult to force them into learning this subject. Thank you.
Okay, thank you. Do you analyze it another subject?
Of course, when we use this syllabus for lectional course and got some information how interesting this syllabus for our students, we took this syllabus for making other curriculum and syllabus for different subjects, and of course we keep this tradition and currently and for this moment too.
Okay, thank you. Because in our university, more popular are psychology or English courses or another not such difficult course. Thank you for report. It's very interesting and it's very important.
Thank you. Thank you.
Thank you. Okay, colleagues, any questions? Okay, and then we start next report. Vitaly Achkan, model learning the online course creative thinking, those learning elementary maths.
A model of learning the online course, Creative Thinking through Learning Elementary Maths, according to the world-class standards for preparing teachers of mathematics. The development of creative thinking is one of the necessary components of the mathematics teachers' training. The same document also mentions that the development of all key qualities of a would-be teacher takes place while teaching normative and optional subjects. Elementary mathematics is one of the most important normative subjects while training students of the specialization, mathematics. The objective representing an educational model of the online course, Creative Thinking through Learning Elementary Maths, and it proving the efficiency of implementing this course while training students of the specialization, mathematics. A model of the online course, Creative Thinking through Learning Elementary Maths, represented in slide. The scientific novelty of the model is that all the traditional components of the course, theoretical, practical and feedback component, are focused on the organization of 4 activities with a special type of task, rich task. It is the activity orientation of the online course on the use of rich TAC that is the basis around which the course model was developed. The model includes 3 interconnected components of the course, theoretical, practical, and forum for feedback, and implies a motivated student's activity with rich task. The theoretical component of the course. This block includes the main theoretical data on each lesson that is necessary for the participants to achieve the goal of the course and audio presentations that explain the main theoretical questions of the course. The practical component of the course. This block includes practical tasks connected with the analysis of different aspects of developing creative thinking. The analysis of methods to learn elementary mathematics aimed at the development of creative thinking, comparisons, solutions, building rich tasks of elementary mathematics. Completing practical tasks of the course encourages such types of activity with rich tasks among students as recognition, classification, solution, and creation. Examples of practical tasks aimed at completing particular types of activity with rich tasks in slide. The efficiency to implement the online course was checked in April to November 2020. To confirm the homogeneity of the groups at the beginning of the experiment, diagnostic tests in elementary mathematics were used, which contained 5 traditional and 5 rich tasks. At the end of the experiment, the students were also surveyed using tests in elementary mathematics, which contained the same number of traditional tasks and all kinds of rich tasks. Fisher's statistical test was used to ensure that the difference between the results of the diagnostic tests in the control and experimental groups was statistically significant. The peculiarity and uniqueness of the course model is that three main components are determined: theoretical, practical, and feedback, that are aimed at students. Activity with rich tasks is a method to develop creative thinking while learning elementary mathematics. Posting the course on the platform, Higher School Mathematics Teacher, allowed providing access to it for a large group of students. The experiment showed that users' acquaintance with rich tasks and their varieties, open and integrative problems, organization of their activity on recognition, classification, solution, and creation of rich tasks encourage the development of a problem statement, elaboration, fluency, flexibility, and originality. This allows us to argue for the effectiveness of the activity-based online course model. Expediency of introduction of a new type of tasks in the process of development of creative thinking in the process of distance learning of elementary mathematics, rich tasks. We see further perspectives in the development of the methodology to develop students' creative thinking while completing rich tasks. Developing and testing the effectiveness of rich tasks for the formation of key competencies of the personality of high school students.
That's all.
Okay. Are there any questions?
Thank you so much. May I ask a question about,
please.
You have told about that you have used, maybe I got it wrong, that you have used these rich tasks with the higher mathematics students. And these rich tasks, I'm asking about the experiment. With which age is it possible to use these tasks? And how do...
Okay, and how?
How do you prepare future mathematics teachers to use these rich tasks? Do they pass any special training to use this specific type of tasks? And then it will help to create, to develop, to ensure the creativity of their pupils.
Yes, I've got what you're asking me. I answer your questions. The next, the answer is the next, that we used rich tasks for teaching elementary mathematics. And for this purpose, we developed this course for students majoring in mathematics, and using these tasks, we choose some stage for them. I mean, the first stage, for example, recognition. These tasks where students started understanding what's the purpose of this task and how to choose these tasks and so on so far. The next stage is, of course, understanding and answering some questions from these tasks and sharing them on different short tasks. And of course, the last one, but the most important, is the creating the task on their own. And of course, getting such kind of methodic, we understood that it's highly important to start give such information not only for students of high institution, but for students from high school And of course, this is the next goal of our research.
Thank you so much.
Any other question, please?
Dear colleagues, please, if you wish, write questions to the speakers in the chat. Okay, and we are going to next, and our next report prepare the team from KRYVYI State Pedagogical University, Vladimir Dal East Ukrainian National University, Donbas State Engineering Academy, and Donetsk State University of Internal Affairs. Okay.
We bring to your attention a report on the topic, the development of logical thinking of high school students through a problem-based approach to teaching mathematics. In this report, we will present the factors for implementing this approach and also briefly comment on the results of the pedagogical experiment. The formation and development of the logical thinking of young people acquires certain features. Mastering the components of logical thinking as the choice of a method for solving a task, a combination of techniques, and the development of a general style of mental activity should not be a side but the main result of learning, in particular in mathematics lessons. Traditionally, the learning of mathematics occurs in the process of solving mathematical tasks. More often, this process requires going beyond everyday experience, when it is not enough just to restore some information to memory. Indeed, in order to solve a task, you need to know some mathematical theorems or rules, you need to analyze the premises or objects which are present in the conditions of the task, use all known mathematical facts regarding the initial data, and derive the necessary consequences from the premises, that is, make analytic synthetic judgments. We try to distinguish the factors that determine the possibility of introducing a problem-based approach to teaching mathematics. They are the following. The first, the choice of a certain type of mathematical tasks. The second, selection of a method for solving mathematical tasks. And the third, drawing up a task system of the chosen type. Let's find out the essence of each of these factors on a specific example. One of the main content lines of the mathematics course at school is the line of equations. The topic equations occupies a leading place in the formation of individual mental operations, and tasks with parameters deserve special attention. The ability to solve these tasks is rightly considered an indicator of mathematical competence. In addition, these tasks allow you to check the formation of students' research skills. At the same time, an analysis of the results of external independent testing in 2021 showed that task 34, as expected, caused difficulties. We know that in the course of algebra and the beginning of analysis, the following types of equations are studied: rational, exponential, logarithmic, and trigonometric. In our study, we focused our attention on the first topic of the 10th grade, irrational equations, and considered irrational equations with parameters. The next factor is the choice of the method for solving the task. It is known that there is no general scheme for solving tasks with parameters. Usually, it is solved using analytical or graphical methods. The main methods for the analytical solving of irrational equations are as follows: raising both parts of the equations to the same degree or introducing of a new variables. It is useful to find the admissible values of the unknown. The next rule is to make equivalent transformations of equations. An example of an irrational equation with a parameter is presented on the slide. A fragment of the chain of logical reasoning is illustrated by the table. This table presents the corresponding stages in the activities of the teacher and students. The logic of reasoning is vividly illustrated by the scheme algorithm. You can invite students to view a dynamic electronic blank to make the answer to the task with a parameter more visual. The third prerequisite for using the task approach, which the teacher must take care of, is the drawing up a task system. When compiling a system of irrational equations, we were guided by the following requirements. The content of tasks must comply with the principles of completeness, consistency, and gradual increase in complexity. Each task of the system must have ideological and technical complexity, and tasks should develop the ability to apply various mathematical methods and choose the most rational of them. We organized a pedagogical experiment to determine the effectiveness of the problem-based approach. The base of the study was the institutions of secondary education of KRYVYI. The study involved 367 students of the 10th grade of different educational profiles. We formed the control and experimental groups using a test method. Examples of the test tasks are presented on the slide. The test contained 20 questions. An analysis of the test results showed that the majority of students scored from 2 to 7 points, which corresponds to level from low to average. Consequently, the conducted research reveals problematic moments in the development of logical thinking. The continuance of the experiment had to study the topic power function irrational equations. The educational process in the control group was carried out according to the traditional method. Classes in the experimental group were organized on the basis of the proposed system of tasks with parameters.
У него даже на нашем
The
языке более
distribution
какой-то
of students
нежный
by
голос.
levels of development logical thinking at the beginning and the end of the experiment is presented on the current slide. Statistical analysis of the results by Fisher's criterion confirms that the distribution of students in the experimental and control groups is significantly different. The positive results of the implementation of the proposed approach are evidenced by a noticeable increase in the proportion of students with above average and high levels of logical thinking. Let's briefly summarize. Logical thinking is the ability to think accurately, consistently, and conclusively, without contradictions in reasoning and mistakes. Logical thinking develops in the learning process, primarily through the learning of the school course of mathematics. Tasks with parameters develop logical thinking. This is due to the fact that the solving of such tasks is aimed at the developing research skills. Prospects for further research consist in the study of individual mental operations of adolescents and in the study of the possibilities of the task approach within of other topics of mathematics. Thank you for your attention.
Dear colleagues, you are welcome to presentation.
Okay, thank you, Ruslan, for your report. Dear colleagues.
Have you any question?
Use chat, please.
Okay, I have a question. Number one, what are the types of tasks in addition to tasks with parameters develop logical thinking? Ruslan.
Thank you for your question. I will try to answer it. First of all, we can say that all types of tasks are aimed to development of logical thinking of our students. But this is true, especially true about cutting problems, for example, when you need to transform some shape by cutting a line straight lines, for example, and planimetric or stereometric, especially stereometric tasks also develop ability to analyze and ability to synthesize and to find a rational way to solve a mathematical problem.
Thanks. What software did you use in your study?
What software?
Yes.
In our study, we often used GeoGebra, of course. This tool is now popular among both math teachers and among school students and university students.
Thank you. And the last question, in your report, you presented the experience of teaching the topic in a Ukrainian school. What do you know about teaching this topic abroad?
Thank you for your question. I think that our mathematics program, Ukrainian, is more or less similar with abroad programs. But in abroad, this topic, irrational equations, is studied more easier. For example, in abroad, mathematics teachers teach their students to solve such tasks, such mathematical tasks, tools wherein both sides of equation to some for second degree, for example. And we, Ukrainian teachers, traditionally try to instill in our students the ability to analyze and to use equivalent transformations.
Thank you so much.
Thank you for your question.
Okay. Does anyone has a question? Okay. Our next report prepare the team from National Center of Junior Academy of Science of Ukraine.
Tools to provide STEM and science education. All of us know what is STEM. It's integration of science, technology, engineering, and math. However, STEM is provided by using relevant digital approach, but not tools that being used. Sometimes we see cases where using of, for example, robotics or 3D printing seems like it's STEM, but actually it's not STEM. The idea of creation of such paper came to us because we have huge experience in using of different tools but we have not seen anywhere systematization of such tools. And also it is very important to have a list of tools that may be used for providing STEM. Okay, digital tools can be divided into three types. For example, it's instrumental tools. It's something physical that's required to have. For example, it is pH meter. It's software tool. To use this, you need only computer, tables, fonts, and it uses programs that set it up at such devices. And also there are some modern tools that are not widely used today, but they have huge potential. I'll talk about all of them more detailedly. Okay, the first part is instrumental tools. It integrates digital labs, digital equipment, mobile phones, and using additional equipment that connected with such phones, and also smart or physiological tools. So here we have digital labs, and digital labs is sensors that connected to some processor that transforms analog signal to digital signal, and after such transformation it's connected by USB with computer where data stored and visualized. This is a very useful tool because it provides possibility to have real-time data. It has its own interface where you can both display and analyze data, and it can transfer such data to Excel where it can be processed additionally. The team of authors that presents such paper also has guidance related to using such digital labs related to chemistry and biology, and also in our department guidance of physics were created. Additionally to digital labs, there are digital tools that only connected to computer but do not visualize analysis of data it's get. For example, it is digital microscope which shows zoomed picture it takes, and analyzing of such picture is required by user. Also to this group of equipment, it's possible to add pH meters, conductometers that do not provide analyzing of data, calorimeters act. The main advantage of such tools is that they are more widely spread and it's easier to have it because they are much cheaper. Also, perspective is smartphones because they have a lot of sensors that's built in, and for example it's lux meter, it's magnetic field meter, it's orientation meters act, and the recent studies tells us that there's possibility to connect professional science equipment to smartphones, and it's make easier to do STEM and science education. For example, it's a picture we can see that pH meter connected to smartphone, and also there are a lot of different specific fields to use smartphones. For example, it's determination of pH of body skin, it's determination of type of blood, it's using smartphone as calorimeter and act. Also, the most perspective from this group, in our opinion, is using of smart tools, or its second name, physiological tools, and it's using of personal, smart, connected tools that takes data that's related to each person. So, for example, it's smart tools that collect data on heart rate, on blood pressure, on EKG, and also it may be, for example, smart weight and other different tools. We already have paper at this field that is in press now, and we are being prepared
second paper on this topic that will be more advanced and will have more practical methods to use such tools. Okay, second group of the instrument is software tools. It include educational ontologies, calculators and modeling environment, and visualizers. Ontological tools are taxonomies that structure in some specific science field and using a link between terms from the most general to most specific. For example, at this picture you can see a structured program chemistry class 10th grade, and it's structured as was noted before from the most general term to the most specific, and it's possible to connect such ontologies of educational program between each other and also to connect them with some practical methods that are studied for this term, for example. And also there's a figure that shows a survey that collect data about students' interest and rank for him list of the work that that will be the most interesting for him. Also, we have few papers related to this field, and the last our studies were devoted to using of ontologies to structurize of educational research of students and simplify their literature review. Virtual labs that model some situations with using of visualization and some engine to study students of some situations. At this picture you can see the laboratory called CoLab, and you may read more detailedly about it at the works of Netherlands professor Dr. De Jong. And also perspective to use are visualizers. At this slide you can see visualizers that show different systems of body of human, and it's easy to use. It's 3D models, it's other different tools that just use to visualize and to study without significant interaction of students compared to previous one. Okay, and the last group is the most modern and perspective tools that are VR, AR, AR analytical apps, AI, 3D printing and 3D modeling, and robotics. We will stop only at one of the tools that we studied the most, because also there are a lot of work related to each of the topics. It's using of Google Lens. We have also a few papers related to this topic. It analyzes its quality of analyzing and possibility to using at Ukrainians classes, and also compares its accuracy with other apps. And our current research is with a professor from Florida State University that also will compare involving of students and enhancing of their knowledge level by using of Google Lens in both Ukraine and USA. Okay, what about Practic? Actually, we take data from one of the most known site in Ukraine related to STEM. It's STEM AI Science, and we have analyzed methods that are represented there. And as showed our analysis, the most works are used as calculators. At the second place, it's using of digital labs, and also very widely used is using of digital equipment. Also, here's interface of such website. I hope all of you know, but if you don't know, STEM Your Science is welcome for you. The link is at the right side of the screen. Also, I want to tell a few announcements and useful tools. First of all, we are been preparing a book related to implementation of STEM. It's very easy to read, and it's written with simple text and high level of visualization. Almost each page have its visualization picture. So it will be published this year. And also I want to share with you easy to use group to be familiar with upcoming conferences. And also you can see the screen structured data on this conference, ICon-MaSTEd 2022. So it will help to you to have real life information about upcoming conferences. And so thank you for your attention. You can find papers we prepared using ResearchGate, Scopus, Web of Science. Here's the email if you have any questions.
Okay, thank you. It's a really useful report. Are there any questions? Maybe something want edit?
If I can just to say thank you for the authors, because we really, first of all, they are making such an important thing when they are attracting adolescents to use the smartphones, mobile phones, not only for entertainment, but first of all, for studying, and in such a way they increase their motivation to study. Thank you so much for such a research, and I think that your book will be very interesting for STEM teachers in Ukraine, and not only in Ukraine. Thank you so much.
Yes, I am agreeing. Okay, thank you. Okay, I have one question. What about students? Did have they some problems, or was it difficult for they?
For them, sure, it's not so difficult because they are living such life. They use such tools in real life, so this is very interesting. But the main problem that's related to Ukraine is that not each student have such a device. For example, if we will compare USA and Ukraine, in USA there will be much more students who wear such, for example, smart tools. So.
Okay, thank you. It's only smartphone, or maybe other gadget?
Yeah, just for example, it's related to all digital tools that were presented.
Okay, thank you. What you realize it on the distance education?
Oh, you know that it's not about topic of the research, but actually,
yes,
I think it depends. Sometimes it's effective, sometimes it's interesting, but I think in most cases it's characterized by a little bit less level of both interaction and effect.
Yes, because all physics have such problem.
Yeah, but combining of distance education and real life experience, it's very effective, I think.
Yes, thank you. It's very interesting, and it's might be useful for all. Okay, any questions? Use chat. Okay, then we have say thank you, Evgeny, and go to next. It's teams from Kherson State University and Taras Shevchenko National University. Report from Valery Kuzmich, geometric interpretation and visualization of a particular geometric concepts at metric space study.
Dear colleagues, we offer you a report on geometric interpretation and visualization of particular geometric concepts at a metric spaces study. The work considers the issues of studying methods of geometric properties of metric spaces in higher school. First, we present some basic concepts related to metric spaces. Such concepts are the distance between the points of space, definition 1, the rectilinear arrangement of points in space, definition 2, the rectilinear set of points in space, definition 3. In the following, we will consider several classical spaces. The metricization is based on simple concepts and which are easy to illustrate even on the material of the school course of mathematics. Formula 1. This space is Rn. Formula 2. This space is CAB. Formula 3. The space is CL. The authors also use the concept of angle in metric spaces, definition 4, and its numerical characteristics, definition 5. With the help of these concepts, it is possible to establish the notion of a flat arrangement of points in a metric space, definition 6, and a flat arrangement of a set of points in a metric space, definition 7. Visualize the mutual location of the 4 points A, B, C, S of the metric space, the distances between which are known. We construct a corresponding tetrahedron ABCS in dynamic geometric environment GeoGebra 3D. Place of vertices are in the center of the system of three-dimensional Cartesian rectangular coordinates space R3, and the vertex B on the positive half axis of the abscissa. When calculating the coordinates of the vertex of the tetrahedron of the ordinate of the point C and the application of the points S, we will always choose non-negative ones. Thus, the oriental tetrahedron is presented on this slide. Since in GeoGebra 3D it is possible to construct a tetrahedron only on the coordinates of its vertices, the authors used the formulas for calculating the coordinates. These formulas are present in this slide. Consider an example 1 of visualization of the mutual location of the 4 points of space C01 in GeoGebra 3D. These are linear functions. In space C01, all distance between points will be equal to 1. In space R3, these points will form a regular tetrahedron. In GeoGebra 3D, the corresponding tetrahedron is shown in this slide. This image can be rotated so that the point of view lies in the plane of the X or Y in this slide. Going to space CL, we change the relative position of these points. The distances between the points will change. The interpretation of this arrangement of points is presented in this slide. Consider example 2. These are linear functions. Having found the distances between these functions in the space C01, we can make the following interpretation of their mutual position in the space R2. Having found the distances between these functions in the space C01, we can make the following interpretation of their mutual position in the space R2 in this slide. Conclusions. The examples of geometric interpretation and visualization of the mutual points placing of metric space given in this paper can contribute to a deeper and more conscious perception and understanding of the metric space theory. The analogy of particular connections between of the points of metric space with the corresponding connections in Euclidean geometry makes it possible to trace the change in the characteristics, geometric properties of space at its metric changes. The use of special graphical capabilities of the corresponding software allows not only to visualize and the mutual points of placing of the metric space, but also to track its change at changing observation point of placing. Thank you for your attention.
Okay, thank you. Really, mathematics is a difficult subject, but we can use it different choice, different skills, themes for our students.
Yes, it is very difficult, because we study this mathematics with geometrical interpretation, because only formulas very difficult, and this very difficult for example, in GeoGebra build very simple figure or body, for example, tetrahedron. Very difficult, because we must know the coordinate this 4 vertices.
Oh yes.
And when we have only lengths edges, no, it is very difficult. And our formula, yes, very easy.
Yes, maybe your program was very useful for astronomy in the spherical
yes, it is very important formulas for the astronomy.
Yes, and astrometry, we can coordinate for stars is very, very useful. Thank you. Dear colleagues, have any questions?
I have.
Okay, thank you, Ruslan. Please.
Thank you for your interesting speech. So you have rich experience about teaching of this topic. And how many your students are successful in it? Thank you.
We have very 5, 6 in one group. The study this subject very small.
And it's our problem, our big problem.
Yes. 5 students, 3 students in the mathematics. Very little, very small.
Okay, but you used this program on the lesson or after lesson?
And on the lesson and after lessons. After lessons, yes.
Okay, for all students or for the Olympical student, for prepare for Olympiad or science?
No, our students prepare works to the students Olympiad, for the mathematical конкурсы. Вот, да.
Okay, thank you. Are there any questions?
I have one
Okay,
question.
thank you. Yes, yes.
And how do you think what we need to do with this problem?
About this problem?
Yes.
We must increase interest in for the mathematics.
And maybe revise mathematics program curriculum.
Yes, yes, yes. But in mathematical programs, very little time for the study mathematics, and it is very difficult.
I agree with you. Thank you.
Thank you for our questions.
We have more disciplines
Yeah.
and
Yes.
very little time.
But mathematics, very important course,
Yeah.
very important discipline.
Yes, very important, but not all understand it.
Yeah, yes, yes.
In the school, not all people study mathematics. They say, I don't not know mathematics.
Because we must given more time for the study mathematics.
Yes, and more mathematics in other subject, on the physics, on the geometric.
Yes, yes, yes.
On
yes.
the geography, on the chemical.
Our work for example, for the astronomy.
Yes, but astronomy in the last year, and they don't study astronomy.
Yes, yes.
They go to the
yes, yes.
Another subject. Yes, thank you, Valerie. You have any questions? Something? Okay, thank you.
I don't have any questions, but I have addition.
Okay.
To my own opinion, we need to introduce some special courses at the university. For example, applied mathematics, maybe, or mathematics in our life.
Yes, yes. Thank you, thank you.
Yes, it's a very interesting new course.
Yes.
Integrated course. Okay, thank you. Okay, we have. There are some comments. Visualization might help students a lot in understand mathematics in general. Yes, thank you.
Thank you.
Okay, we go to next. The teams from Kyiv, from Kyiv National University of Trade and Economics and Bogdan Khmelnytsky National University of Cherkasy. And please, Oleg Pigulsky and quantum mechanism approach to simulation of molecular crystal thermal conductivity. Please
Good
start.
afternoon, everyone. I am Oleg Pursky from Kyiv National University of Trade and Economics, Chief of Department of Computer Science and Information System. Dear colleague, let me present to your attention the result of our research on the topic quantum mechanical approach to simulation of molecular crystal thermal conductivity. Firstly, about the problematic shortly. This study is devoted to implementation of scientific achievement into the educational process of physics specialties students in the framework of study course solid state physics. Implementation of the latest scientific achievement into the educational process is an important feature of modern physics education. Students obtain an education that provides a general understanding of the universe nature on the basis of modern knowledge in the field of physics. In the study course of solid-state physics, for example, Introduction to Solid-State Physics by Charles Kittel, the higher transfer process are considered superficially and it is based on Debye's ideas. But the Debye model cannot adequately describe the thermal conductivity behavior of crystalline dielectrics. We observed significant differences between the prediction of Debye theory and the experimental results. In this study, we present a quantum mechanical approach that can adequately describe the temperature dependence of the electric crystal thermal conductivity. The basic provisions of quantum mechanical approach are studied by students in the framework of university study course, solid-state physics, and are based on Einstein and Debye classical models. This approach is based on the assumption that in the electric crystal head is transferred using phonons, Debye models, and thermal diffusion between the thermally activated neighboring quantum mechanical oscillator directly from side to side on a time scale of 1/2 of oscillations, Einstein model. In terms of this consideration, the thermal conductivity of molecular crystal are simulated in the framework of thermal conductivity model where heat is transferred by low frequency phonon. We take into account phonon rotation coupling and above the phonon mobility edge by diffusive models. Using simple molecular crystal as an example, it shows the dualism of the nature of heat transfer process in the temperature region of the order or above the Debye temperature. The obtained result will be useful for implementation in educational process in the study course solid-state physics, in particular for understanding the features of heat transfer in high temperature region of dielectric crystals existence. The first stage of approach is devoted to modification of the biomodal thermal conductivity to take into account the heat transfer by low frequency phonons and diffusive models. Generally accepted that thermal conductivity of the electric crystal can be described by Formula 1, where V is sound velocity, omega d is the Debye frequency, L is the phonon length path, and A is the lattice constant. Corresponding equation that give us calculated above mentioned parameter presented by Formula 2 and Formula 3. At high temperature, oscillation models participating in the heat transfer are essentially limited, but it cannot become smaller than half of the phonon wavelength. And the side-to-side hair transfer proceed as diffusive process. In this case, we can describe this transition by the formula 4, where alpha is a numerical coefficient of the order of the unit. Equation 6 is well known a Kyiv criterion, which implies localization. The excitation whose frequencies are above the phonon mobility edge are localized or diffusive. Since completely localized models do not contribute to the thermal conductivity, it's supposed that the localization is weak and the excitation can hop from side to side diffusively. In this case, integral of thermal conductivity 1 is subdivided into two parts, describing the contribution from low frequency phonons and high frequency diffusive models. The second stage of approach is devoted to accounting translation rotation interaction in the Biomodal of thermal conductivity. The heat transfer in molecular crystal in high temperature region is determined by phonon-phonon and phonon rotation interaction, and that phonon rotation relaxation time is described by 1 and 2 phonon scattering process. Using the equation for 1 and 2 phonon relaxation times, the phonon band-free path of 1 and 2 phonon scattering can be described by formula 8 and 9. Corresponding parameters that included in this formula presented above. In this case, we have combined phonon band-free path that can be written by formula 13. In general case, combined band-free path can be described by formula 14. And the frequency omega 0 can be found from the condition and formula 13, 16, and 17. In this case, integral of thermal conductivity splits in two parts, describing the contribution to the thermal conductivity from the low frequency phonon and the high frequency diffusive model. In the high temperature limit, this contribution described by the formula 18 and 19. At this slide, you can see subject for study, object for study. The object for study are a solid dichloromethane, chloroform, and cyclohexane. As you can see, this object consists from different molecules with different types of translation rate, different types of translation rotation interactions. At this slide, you can see the result of research. In figure 1, presented the isochoric thermal conductivity of solid cyclohexane. Solid line is a fitting curve for isochoric thermal conductivity, and presented contribution of phonons and diffusive model to hair transfer. Figure 2 presented the result of simulation for the whole thermal conductivity of solid chloroform. and the contribution of phonon and diffusive modes to hair transfer. Figure 3 presented the result of simulation for the thermal conductivity of solid or metal and the corresponding contribution of phonons and diffusive modes to hair transfer. As shown in figures 1, 2, and 3, the simulation result for thermal conductivity of solid chloromethan, chloroform, and cyclohexane are good agreements with experimental result. Differences do not exceed 5%. And conclusions. This study devoted to implementation of scientific achievement into the educational process of physics specialty students. Present approach is very useful for students because it demonstrates the dualism of nature of hair transfer process in dielectric crystals. The basic provisions of quantum mechanical approach are studied by students in the framework of university study course solid-state physics and are revised on classical model of Einstein and Debye. In the framework of this approach, the thermal conductivity has been simulated under assumption that in molecular crystal head it's transferred due to the phonon-phonon interaction and thermal diffusion between the thermally activated neighboring quantum mechanical oscillator. The results obtained in this investigation demonstrate that the quantum mechanical approach for thermal conductivity of molecular crystal is adequately described the experimental thermal dependence of thermal conductivity and can be useful for simulation of hair transfer process features with different types of molecular rotation motion. The presented quantum mechanical approach can be useful for implementation in educational process in the study course solid-state physics, in particular for understanding the features of hair transfer in the high temperature range of dielectric crystal existence. Thank you for your attention.
Okay, thank you, Oleg. In previous topic, we speak about difficult of the mathematics, but theoretical physics is more difficulty for our student, and without visualization, I don't know how we can study our student, your students. It might be very interesting and very useful, such programs, such tasks, and such research. Okay, colleagues, are there any questions? Maybe somebody wants to edit something? Okay. I can say some questions. I'm sorry. Okay. Have you got the technology, your personal technology, or this program is universal? Where they program it?
This result is our result, scientific result, but in faculty course, our university, Kyiv National University named Taras Shevchenko, this result used for in master programs, in particular in course of course thermophysical properties of solids.
Okay.
The most important result of our research that present in this, we have the model that describe hair transit process that adequately described the experimental result of thermal conductivity in the framework of classical theoretical model Einstein and Debye that study by student in the course of solid state physics.
Okay, thank you. In your report, you speak about some solid material, but did your students modeling other material?
This result can be used only dielectric crystals.
Yes.
Or other substance is not for usage.
Yes, okay, I understand. But have which problem or why problem have your students when you study this?
The main problem, they basically understanding student the theoretical basis for mathematical theoretical basis for this model. This fundamental knowledge in mathematics and physics for understanding this model.
Okay, because our students also has a problem in the mathematics and programming because they know some language for programming, but they don't use it. Okay, thank you, Oleg.
Thank you.
Are there maybe somebody want to say anything? No. Okay, thank you. And then we go to next report. This from Kherson State University from Natalia Golovko. Experience in the development and implementation of a system of visualizing teaching cases in physics using digital computers measuring system Einstein.
I want to present you an article on the subject, experience in the development and implementation of a system of visualized teaching cases in physics using a digital computer measuring system Einstein. Time has come to form a new educational system. This is confirmed by the UNESCO initiative on the future of educational for 2050 and thereafter and provides an operation to understand how education can shape the future of humanity and the planet. Around the world, educational is a top global priority, a major driver of human empowerment. Realizing the importance and the need for educational reform, the new Ukrainian school concept draws attention to 10K competence of a modern person, including mathematical competence, basic competence in the natural science and technologies. Today's future of countries provides the most popular today development of research, capacity and strengthening of natural science engineering, education, and open learning, including the use of open educational resource, free and open source software, open learning platform. The trends that actively expanding and carrying out this process present on the slide. Introduction of the case method in the educational process gives an opportunity to realize certain trends and tendencies of education and contributes to the formation of certain competence defined above. The case method as a teaching tool can help attract students to research in any discipline, especially physics. Using the interdisciplinary connection between science, math, and computer science through a virtual physical cases environment. The purpose of the article is to present the experience of developing and implementing of the virtual physics cases study environment as a means of open learning physics, improving the quality and motivation of teaching physics of students. Developing and implementing a system of visualized learning cases in physics involves a combination of previously developed virtual physics cases with using the digital complex Einstein. Their use in the education process gives an opportunity to increase students' motivation to learning, and it accordingly leads to physics education quality increasing. In our study, visualized learning cases is a computerized cases, which allows combining a virtual experiment with real performance of experimental tasks. The use of such tasks allows transferring information about the studied objects, process, and phenomenon directly to a personal computer. To process the obtained information in real time, to provide the teacher with information about the possibilities of learning the specific future of students' mental activity. Detectively tested use the visual imaging in teaching physics can transform visualization form and auxiliary in illustrative tool into a leading productive methodology tool. Teacher can choose the cases, type, and implementation using the Einstein World app. It should be recognized that visualization of learning material should not attend, but attract attention and motive. In this case, it will be effective. The Einstein learning platform combines software and set of sensors for physics, chemistry, and biology, situational physics. The software for the sensor set can be downloaded on both Android and iOS. MyLab is a mobile application that allows restoring and analyzing data from Einstein sensor in real time. It can display data in graphs and allows monitoring several different relating indicators to study dependence and rules. Einstein World has a set of ready-to-use interactive exercise using sensor. Einstein World is easy to use interface, allows sorting is a problem by topic, physics, chemistry, biology, environment, by language, by age, by sensor to be used. The disadvantage of the Einstein World program is the very few tasks in Ukrainian, but its value is the ability to develop own interactive tasks. This software can be used to design virtual cases using a set of sensors. It extends cases using in physics study and visualization them. So we developed a number of visualized physics case for 19th grade students of general secondary education. The model of the educational process organization using the virtual case study environment and the Einstein World program is shown in slide and consists of the following components: teacher, students, virtual educational environment, educational platform, and Einstein World application. The result of our work was development of the algorithm of teacher activity, step-by-step instruction for the student of working with a visualized case, a methodological recommendation for organization work with case. Present on the slide the example of using a visualized Harry Potter case for 19th graders in geometrical optical study and step-by-step instruction. The purpose of the visualized case is to deepen student knowledge in geometrical optic, test the knowledge of the laws of geometrical optic, rectilinear diffusion of light, reflection, and refraction of light, develop students' cognitive interest, motivation sphere, and improve such basic competence as critical thinking, technologies, and information literacy and cooperation skills. There are the variants of the organization of work with visualized learning case are the case as an experimental task may be used in the intent in the class of offered as homework. A possibility variant of work with the case is the execution of an educational project based on the formulated case assignment, and the proposed case can be used as a laboratory work. Type of lesson is a lesson of practical skills formation. In order to investigate the appropriateness of using this type of lessons, the components of motivational structure related to the level of pretensions were investigated by questionnaire. Students of the 19th grade of Kherson Academic Lyceum of Kherson State University took part in the study. Group A, the control group, got written or verbal task of the traditional type. Group B, experimental, worked with visualized case. For the study, 3 components of the motivational sphere were identified. These are 3 main groups of motives, each of which can be investigated and analyzed. The list of groups of motives is shown on slides. Comparison of the results of the questionnaire presented in a figure shows the presence of positive improvements in the levels of motivational sphere of students. Compared to the control group A, students in group B had an average increase of 2.1% in the indicator of intrinsic and cognitive motives at the time of the visualized learning cases. On the contrary, the tendency to discontinue the work performed decrease, which indicates an increased interest in the performance of situational tasks. During research of the second set of motives, it has been established that such elements as evaluation of degree of evolution effects expression, component 9, evolution of level already achieved results which are connected with the opportunity in this activity, component 10, evolution of potential, component 11, do not differ significantly in importance into groups. The analysis of the results of the questionnaire on the third group of motives showed that in group A and B, the students' distribution on the element understanding how much the task setting in initiative or directive is significantly different. It indicates a positive trend of students' motivation to study physics as a help of visualized case. The survey's results showed there were positive improvements in the levels of the components of the motivational sphere related to the students' attraction level. The results of the students' survey were statistically substantiated using the T-Wilkins statistical criteria, less 0.05. And so, in the context of active transformation of Ukrainian education, special attention should be given to innovative teaching method, technologies, and the techniques that will help to embody the ideas of open education, STEM education. The use of visualized learning cases in physics allows teacher combining experiments, interactive multimedia, and convenient analysis software on any tablet or computer to inspire students, giving them the opportunity to immerse themselves in the exploration of physical process and phenomena. The combination of virtual and real experiments allows immediately realize the knowledge. Visualization of tasks increases students' interest in physics studying and encourage them to further work. Studies of the motivational sphere have shown the expendency and necessity of using visualized learning cases in teaching physics. The prospect of future research is to develop a system of visualized learning cases in other sections of the school physics course and a methodological recommendation for their use. Thank you very much.
Okay, thank you for your report. It's also useful program and useful report. Okay, Jana, can you want comment?
I just wrote in the chat the comments that thanks for the authors for their research, and I hope that there will be more materials in Ukrainian language, so more teachers and pupils, Ukrainian pupils, can use this program, and it will help them in their future learning.
Yes, I agree. Thank you. Okay, why do you use this system, Einstein? Are they the same other programs?
Sorry.
Okay.
It's because we have in university this program is this Dutch. Sorry, my English. Ми просто маємо в університеті саме цей набір датчиків, і його зараз популяризують у школах, тому ми з ним працювали.
Okay, I understand, because it was, maybe there are in the many school in future.
Yes,
availability.
And many teachers звертались до нас за допомогою, щоб працювати саме з цим набором датчиків, бо немає інструкцій, щоб з ним працювати. Тому до нас звертались, тому так і випала на нього саме.
Okay, because it is really problem instruction. Because in the school have можливості, да, тобто ability to buy, to have such датчики, да, тобто such, but they can't use it.
Yes.
Okay, I say the same question. What problem with the student? Did they have a problem?
Students don't have problem with to use this program. It's very
simple.
Справа в тому, що якраз експеримент проводився на учнях з гуманітарних класів, які вивчають додатково іноземну мову, тому їм навіть було добре, що програма була англійською, бо вони добре справлялися з нею.
Okay, it was integrated course, English and physics.
Yes.
Yes, it's useful also. Thank you. Thank you for your report. It's very interesting and useful system. And I don't know it. In our university, we use the other program and other датчики. Okay. Okay. Are there any questions? Maybe comments? Okay. Thank you, Natalia. And we go to the next report. It's from University of Novi Sad and Center for Social Work in the city of Novi Sad. Report Maria Stojanovic about relationship between achievement in physics and mathematics and family function, from physics to psychological.
Good day to everyone. My name is Maja Stojanovic. I came from the University of Novi Sad, Faculty of Sciences, Department of Physics, Republic of Serbia, and I will present our paper relationship between achievement in physics and mathematics and the family functioning. My presentation will have 4 parts. First, something about introduction, then methodology, results that we obtained, and at the end, a conclusion. So let's start. The development of pedagogical and psychological theories causes an increase in the number of examined factors, cognitive and non-cognitive. And the aim was to determine and understand student achievement as completely as possible. Some cognitive factors are cognitive load and mental effort, mental load, which are interconnected, while some non-cognitive factors are personality traits, motivation, and family environment. The result of the family environment is reflected in its contribution to the formation of the child's personal, properly directed characteristics and the versatile development of their abilities. The same functionality of the family was reflected in commitment, trust, and solidarity. So family cohesiveness represents togetherness and emotional connection between family members. It is measured by examining emotional connections, borders, coalitions, how decisions were made, its interests and reactions. One of the most accepted models of the family functioning is Olson's circumplex model. This marital and family system model has been widely used for 25 years and consists of three dimensions: cohesion, adaptability, and communication. Figure on the slide show a schematic representation of this model. And now a few words about methodology that we use. Our paper examines the connection between family functioning and students' achievement in physics and mathematics. Within the family functioning, the most important factors are the parents' education and the number and structure of the family. The study involved 80 students, 7th and 8th grade of the elementary school in Novi Sad. So they are children aged between 13 and 15, and data were collected in early 2019. Phases 4 is the latest version of the family self-descriptive questionnaire designed to measure the cohesiveness and family adaptability, which are the central dimension of the circumplex model and of the marital and family system. For students' achievements in mathematics and physics, their concluded grades in the semester were taken. So let's see which results we obtained. The average score achieved on the two balanced scales of the Phases 4 questionnaire, we were converted to percentile score using a conversation table and showed that the family members of the respondents are connected and flexible. On the other hand, we can say on unbalanced scale, percentile score indicate a low level of rigidity, disunity, chaos, and networking. Family communication is at a high level, which means that the family members feel good about communication and care little. Family satisfaction is moderate, so family members are somewhat satisfied and enjoy some aspects of family functioning. Parent education significantly affects achievement on the chaotic dimension. Namely, children whose parents have completed primary school achieve the highest results in this dimension, followed by children whose parents have completed higher school. Parental marital status has a statistically significant effect on flexibility, cohesion, family communication, and family satisfaction. Children whose parents are married score significantly higher on all four scales, followed by children whose parents live in the extramarital union. The worst results are achieved by children whose parents are divorced. The results that we obtained indicate that there is a negative relationship between the scale of networking and the chaos with grades in mathematics. In other words, low levels of chaos and networking follow higher grades in mathematics. When it comes to grades in physics, they are positively related to the scale of balanced chaos. Namely, high results on this questionnaire scale are followed by high grades in physics. So the lower the level of chaos means that the higher the level of cohesion and the students' achievement are higher. In the conclusion, we can say the previous research agrees that the family environment is an important factor determining students' development, functioning, and school success. The role of the teacher in educational system, in addition to the transfer of knowledge, includes encouraging and directing the development of students, which is possible only if the teacher is able to see and understand all the factors that could affect him. Therefore, understanding the connection between the student's achievement and in school subjects, in mathematics and physics, and family functioning is important for teachers to develop competencies to adequately respond, encourage, and motivate students, and to achieve optimal school achievement. Therefore, the next direction of curriculum development should be in order to enable teachers to develop the necessary competencies. Thank you for your attention, and if you have any questions, I'd be glad to answer on it.
Okay, thank you, Marie. Are you here?
Yes, I'm here.
Oh, okay, thank you. It's very interesting because I see such research many years ago, but I don't see such difficulty in this year, in this time.
Yes, we have.
Yes, okay. Are there any questions, colleagues? Maybe you.
I have a question.
Okay, Oleg, please.
It's very interesting research, somewhat unexpected research and questions of the event of family. How can technology of physics law influence on the family structure of functioning of family?
Hello, I'm a colleague, and I didn't understand you very well, but if I hear, then I must say it is very important to see larger number of factors which influence on grade in physics, because in that way we can do something to change our approach in order to increase students' knowledge level and scientific reasoning.
I see. It is general development in scientific direction of physics and mathematics can affect to family function.
Yes.
Okay, are there any questions?
To just, if it's possible to add a comment, I want to say a special thank you because, for example, the tools and the model you have described is not widely described in Ukraine in our sources. So it's very interesting, and I think that we will try to find more information. How, for example, phases 4 can we use? Is it possible in different cultures to use these two
questionnaires? Self-functioning questionnaires.
Thank you so much for this. That's a new tool for us.
Thank you.
Okay, yes, I agree. Okay, what kind of work can teacher to use for training students from difficult families, dysfunction families? What kind?
We thought that university should prepare students as future teachers better for teacher role, and in that case take into account these factors such as dysfunctional family, and show them how they can work with students from that group.
Okay, I understand.
Yes, because
maybe more time for the student.
Yes, because when we teach students, we usually take into account the ordinary, the functional, cognitive, and family that function well. Yes, not that there is a problem with social status.
Okay, I understand. Thank you. Did you explore how long parents was discovered, and did you see influence it was 1, 2, 3 years ago?
No, we don't.
Okay.
But it's a good idea in the future research, maybe.
Yes, it's very interesting. Yes. How long time?
Yes, yes.
Okay, thank you.
Okay, thank you.
And finally, question. What do on your things? Why has influence in the family different to achievement on physics and mathematics? Why different?
Well, we know that grades from physics and mathematics are in correlation, but if we look other factors as non-cognitive factors, then we should also try to understand better why results are as it is, why there are maybe a little bit lower grades from physics, because you know, some students see physics as something difficult, and there are more hours in mathematics, and because of that, mathematics is more easier for them, and that is number of hours. It's not the only factor which affect on their grades.
Okay, maybe. Okay, thank you.
Okay.
Are there any questions?
Our workshop continues, and we welcome again team from Republic of Serbia for the presentation their next article.
Yes.
Yes.
Okay.
Scientific concept related to physics from the perspective of students of biology.
Good day to everyone. My name is Maja Stojanovic, and I came from University of Novi Sad from the Faculty of Sciences, Department of Physics from the Republic of Serbia. And I will present our paper, Scientific Concept Related to Physics from the Perspective of Students of Biology. My presentation will have 4 parts. First one will be introduction, then I will speak about methodology, and then results that we obtained, and at the end, the conclusion. So let's start. If we start with the aim of modern institutional education, and teaching as its primary forms of organized formation, which represents a complete and logically consistent system of knowledge and concept for students, as well as the outcomes of the educational process in the classroom, then we can say it is clearly why many studies pay the special attention for examining how students acquire scientific concepts and how they use the scientific terminology. So this paper is also focused on this issue. Proper understanding of scientific terms is in direct correlation with the quality of students' knowledge. Therefore, if we can influence on conditions which cause students better understanding of scientific terms, that results of our influence will be higher quality of students' knowledge. In order to find the best way through which we can influence on students' understanding of scientific terms, we can say quality of students' knowledge, we must take into account a student's motivation for learning science. Motivation affects the reason students learn and the intensity and duration of activity and learning. Bandura explains that the learning and motivation as reciprocal interactions involve three things: personal characteristics, environmental context, and the behavior. Then I will speak about methodology. The subject of our research was to investigate how students of biology understand certain scientific concepts in physics that are relevant to their profession and how much they are motivated to learn physics. So in our paper, we use three motivation components. First one was intrinsic motivation, and intrinsic motivation represents inherent satisfaction in learning science for its own sake. Then we have self-efficacy. Self-efficacy, students believe that they can achieve well in science. And the third one, self-determination, is the control students believe that they have over science learning. For instruments, the test for determination students understand a basic concept of physics contains of 13 items. And we also use questionnaire developed by Glynn. It's scientific motivation questionnaire, and we applied it to examine students' motivation for learning physics. As for participants in this research, we include 89 first year of undergraduate students of biology from University of Novi Sad, from Faculty of Sciences, and this research was conducted at the beginning of the course Biophysics. Data were analyzed by using SPSS Statistics 20. And what results we obtained? Main results shown that the students do not understand some basic concept related to physics. Concretely, for example, students properly adapt some concept of isotropy, indicative and thermal balance. For example, with the concept of isotropy, students of biology encountered in the context of explanation of muscle cells and skeletal musculature, and the concept of indicative students have met in the framework of teaching chemistry using litmus paper, because determination of acidity of the environment using litmus paper is often used in biology. So it is important to determine in what kind of environments growing plant or what kind of agency is necessary to act, for example, in order to foster the growth of plants or to destroy the certain bacteria. On the opposite side, the concept of normal distribution, resolution, and latency are still unclear for them. So when they have graphic representation of the results and their interpretation, that represent a major problem for the students. So students were mostly wrong also regarding with this question, and according to their beliefs, normal distribution is identified with the equilibrium or with the equivalent conditions, while some students also the normal distribution represents the relevant condition. We obtained that a medium level of students' motivation for learning physics concretely, and also motivational components were approximately the same assessed. Slightly results for the self-determination were higher than for self-efficiency, which can be seen on that graph. And if we compare the results on knowledge test and their motivation for learning physics, we get that the students with less motivation are less precisely answered on questions related to the knowledge of the concept, while students with a higher motivation for physics, we can say they are more precisely answered on the same questions. This results in phases the importance of using more modern approaches to high school teaching that will cause higher motivation for learning physics in order to get higher students' achievement and their better understanding of scientific concept. So we can say that in our paper, the aim of this research was to determine the level of knowledge of the basic concept used in physics, students' motivation for learning physics, and to determine the potential impact on the motivation of students' response accuracy when defining concept. Certain terms that are incorrectly adopted, indicating to the need to change the educational content and to encourage more evident connection between materials. We can say it is necessary to apply new approaches in teaching high school physics, which will cause higher increasing of motivation to learn physics, and of course, the better understand physics concept. Thank you for your attention, and if you have any questions, I'll be glad to answer on them.
Okay, thank you, Marie. For a second. Okay, dear colleagues.
Thank you so much. Really very interesting talk. Is it possible to ask something a little bit more detailed about the approach? You have told that we have to use another approach, different approach. Can you name some that you consider as the most effective in this situation?
For example, experiments or multimedia, this kind.
Okay, thank you so much.
I have questions too. You write in the article that the survey was conducted in the year 2016. Perhaps you repeated the survey again.
Yes, my colleague will answer.
Yeah, we didn't repeat because we changed our approach, and students have a different course.
We changed the accreditation, and there is a subject not biophysics, but physics for biology students, and there is some difference between curriculum.
Okay. And the second question, you also wrote about the importance of using more modern approaches to high school teaching. What kind of methods exactly?
Well, as Professor Maya said, we should use more student-centered approaches as experiments or multimedia approaches in teaching physics, or some virtual experiments, etc.
Because like in this COVID time when we have online teaching, we use fat simulations, for example, to do some laboratory work or something like that, because the faculty was closed there. So we have distance learning, yeah.
Oh,
Okay, thank you. Any questions, please?
yes, Evgeny. Yes.
Yeah.
Ah, no. Okay.
Thank you.
So
And
if there is no any question, I would like to thank you to the conference and to organize this work and this session, because you're such during this difficult time for you. We see it on our television, and the situation in Ukraine is very bad. So thank you thank you very much.
Thank you for your report. I see a hand. Raymond.
yes, we are going to next presentation, and we welcome for the first time to our seminar a representative from South America, in particular from Colombia, Bogota. Hugo Aya from the Universidad Distrital Francisco José de Caldas will present his work using smartphone sensors for teaching mechanical oscillations. And we have his presentation. We start or we...
Hello.
Hello. You hear me?
Yes.
Yeah. I sent yesterday email with a question. If I can present my report in Russian, because
yes,
I speak better Russian than English.
Hugo Aya, yes, так, мы, этот вопрос обсуждался специально с организаторами конференции, и в качестве исключения вам предоставлена возможность предоставить доклад на русском языке. Пожалуйста, начинаем.
Большое спасибо.
Показываем презентацию мы или вы сами демонстрируете?
Я сама смогу показывать.
Хорошо.
У меня сейчас проблемы с батареей маус, поэтому трудности сейчас. Сейчас. Я думаю, что лучше вы показываете мои презентации, потому что я не смог здесь.
Тогда, наверное, прекратить. Ага, все, я вижу.
Я включила презентацию.
Надо сразу отключить, потому что на экране не видно.
Yes.
Можете отключить сразу, прекратить демонстрацию для того, чтобы...
Да. У меня здесь просто сложности с компьютером. Сейчас.
Світлана Леонідовна, уберіть доступ
Ага, я зрозуміла, да.
І потім знову, будь ласка, увімкніть, і я увімкну сама.
Угу. Ага, не в... Угу. Все можете.
Все, можно?
Да.
Могу начинать?
Да, начинайте.
Извините за все эти сложности. Меня зовут Уго. Я живу здесь, в Колумбии. Я учился в Кишиневе. А много раз я был на Украине, в Одессе, и много раз купался на Черном море. Я хочу вам показывать вот результаты последний опыт, который я сделал с студентами. Я работаю в университете, и я сдаю уроки студентам на физике полупроводников и физика колебания и волн. И например, я всегда стараюсь придумать новые эксперименты для студентов. Например, когда мы ходим на занятия в университете, я сделал, например, такие эксперименты, как употребление звуковых датчиков, чтобы измерить скорость звука. Но как мы на целом мире были на пандемии, мы сидели дома и не смогли ходить в университет, и поэтому было очень трудно заниматься опытами с студентами. Я читаю уроки для студентов электроники, но поэтому я придумал такие эксперименты с смартфон, датчики смартфона. И можно на следующий, пожалуйста. Следующая, пожалуйста. Ну и последние годы внутренние датчики смартфонов стали использоваться для выполнения экспериментов по механическим колебаниям. В других случаях телефонные датчики также используются в качестве звуковых преобразователей медицинских приложений. Датчики MEMS, Microelectromechanical System, используются в многих отраслях промышленных, таких как автомобильное строение, экономическая промышленность, медицина и так далее. Датчики измеряют интересующую перемену через разные промежутки времени. Количество измерений в секунду сделанных датчиком называется частотой дискретизации. Когда измеряемая перемена изменяется очень быстро, в течение времени необходимо настроить частоту дискретизации таким образом, чтобы данные, полученные датчиком, были репрезентативными для временного изменения следуемой перемены. Можно на следующий, пожалуйста. Вот, здесь можно посмотреть то, что я сказал. Если частота не такая, как нужно, тогда эксперимент не может проходить как нужно. Среди многочисленных экспериментов с механическим осциллятором можно отнести физический маятник и затухающий осциллятор. Для выполнения этих экспериментов существует мобильное приложение под названием Physics Turbo Suite, который позволяет выбрать датчик смартфона, который вы хотите использовать, настроить частоту дискретизации и создать файл данных. Это самое главное, потому что есть много приложений, которые потребляют датчики смартфона, но это приложение, мне кажется, что очень хорошее, потому что создает файл CSV. CSV значит comma separate values. Такой файл можно посмотреть в компьютере. На следующий, пожалуйста. На рисунке показаны оси смартфона. Ось X направлена в горизонтальное направление вместе с осью Y представляет собой плоскость, на которой расположен дисплей смартфона. Ось Z находится в нормальном направлении для отражения. Смартфон имеет несколько датчиков, как акселерометр, гироскоп, магнитометр, etc. И так далее. Каждый из которых может измерять интересующую перемену на каждой из этих осей. Следующий, пожалуйста. Следующий. Вот. Я специально выбрал эти два эксперимента. Первый – это физический маятник. Как настроить этот маятник? Для настройки физического маятника пластиковой или деревянной линейки делается отверстие, затем смартфон фиксируется на одном конце. Этот маятник фиксируется от опоры через одно из отверстий в линейке. Он колеблется во время приема данных с помощью гироскопа смартфона. Должен быть сгенерирован SSL-файл. Позже данные будут проанализированы на компьютере. Вот. D – это значение, это расстояние от точки опора до центра масс смартфона. Для каждого положения отверстия меняется положение. Для каждого положения отверстия необходимо взять значение угловой скорости и создать SSL-файл с данными. Следующая настройки. Нет, назад. Вторая настройка – это затухающий осциллятор. Как мы настроили? Затухающие настройки могут быть сделаны для создания затухающего осциллятора. Смартфон утверждается с двух верхних крайних точках двумя струнами, как показано на рисунке. Струны фиксируются с неподвижного положения, чтобы смартфон мог колебаться в направлении ось Z. Это маятник катится вместе с приложением, который активирует гироскоп и генерирует файл данных SSB. Результаты. Следующий, пожалуйста. Самое интересное, что получается, что, как показано на фигуре, что мы, получается, очень большое количество данных. Например, на этом графике показано более 23 тысячи данных, которые я нарисовал. Самое интересное, что, например, когда мы импортируем файл to computer, очень трудно работать с этим файлом например, на программе Excel, because работаем с большим количеством измерений. Поэтому надо, чтобы студенты употребляли другие программы, как Python или MATLAB или математика. Это самое интересное, потому что когда я работаю на лаборатории с студентами, мне нравится, что студенты всегда смогли измерить и что-то доказать, как меня учили в университете в Кишиневе. Это самое главное для меня. Поэтому это было сделано во время пандемии. Я им сказал через интернет, как это сделали. Они все это делали дома, и потом мне послали свои доклады через email. Следующее. Вот, например, то, что они сделали, мы сделали, это как найти частота колебания. Они употребляли как на русском. Это на английском fast Fourier transform. Это быстрое преобразование Фурье. Есть разных программах, как, например, Python. Я это сделал в Python. Все данные другого данных, но те данные, которые мы смотрели на прежнем фигуре, а из этих данных мы сделали это преобразование, и так получилось. Но как здесь написано, простой discrete Fourier transform is очень трудно сделать обычными методами, поэтому надо употреблять вот этот метод fast Fourier transform. Здесь доказано, что, например, на этом случае частота около 1 Гц. Следующий, пожалуйста. Вот, с этими данными можно много разных проблемы решать. Например, можно интегрировать данные или сделать производные. Например, это какой тип интегрирования. Как датчик дает скорость, угловая скорость движения. Если интегрирует через этот метод, который написан на этом формуле, можно найти угол движения. Например, в этом рисунке синяя – это скорость, угловая скорость движения, а черная линия – это угловое положение майник. Следующий. А все это сделано на Python, или иногда студенты тоже делают на MATLAB или математика. Вот, на следующий, то, что мы получили, это движение сатугающего колебания. И как вы видите, тоже получается очень хорошие результаты от этого движения. И отсюда можно найти как называется, Констант сатухания. Как это сделается? Следующий, пожалуйста. Вот функция, которая показывает, как изменяется с временем пик движения. Это третье выражение. Из этого можно получить из данных констант сатухания. Если мы сделаем производное, получаем четвертое выражение, а с этого можно получить гамма из пятого выражения. Это Т, это период движения, а можно из данных тоже получить этот период. А есть другой метод, который можно использовать для получения констант сатухания. Следующий, пожалуйста. Вот. На прежнем надо посмотреть прежний, пожалуйста, прежний, да. Здесь как делается? Надо измерить пиковое положение между двумя последующими пиками, а с этого можно получить гамма. А на следующий метод, пожалуйста, следующий, это надо измерить два пиковые положения. Первый называется омега-0, а второй положение, когда есть половина первой. Тогда гамма можно получить через эту формулу. 1 на t логарифм омега дроп, омега-1, первый омега на второй омега. Значит, 1 на t логарифм 2. И все. Следующий, пожалуйста. Как видите, это похоже, что очень простые опыт, но для меня мне кажется, что с этих экспериментов можно получить очень хорошие результаты. И большое спасибо. Не знаю, если будут вопросы. Но извините, мой русский не очень хороший, потому что моя жена не русская, не украинка, колумбийка. Я ни с кем не говорю по-русски, но стараюсь понимать все-таки.
Ваша мова чудова, і ми всі вас чудово зрозуміли.
Немножко понимаю український, немножко.
Чудово. Ми будемо спрямовувати наші зусилля, щоб ви почали краще розуміти українську мову і здійснили поступовий перехід від російської до української.
Спасибо, спасибо, спасибо.
А еще лучше мы у наших врагов заберем еще и язык, соответственно, любой, который у них есть.
В усіх розуміннях цього слова.
Ну, я думаю, что... Да, спасибо. Я только хотел сказать, что я желаю, что на Украине все будет хорошо, и что будет мир и покой в будущем. И желаю, что вам будет лучше.
Чудово.
Спасибо большое.
Very well. And we have a question in the chat. Профессор Хьюго, есть ли у вас данные, где вы вычисляли процентную погрешность измеренной вами величины по сравнению с теоретическим значением, используя датчик смартфона? Если есть, то какова эта процентная погрешность?
Поскольку это, например, здесь на первом опыте, на который сделали физический майник, можно сравнять с теорией, потому что есть модель математический, который можно смотреть. Но до сих пор я это не сделал. Но благодарю за вопрос и буду сделать на следующий раз, который будет в этом семестре. Но на второй, поскольку очень трудно с теоретическим пониманием сказать, какой будет констант сатухания, по-моему, невозможно сравнять с теорией.
Thank you for your answer. Благодарим за ответ. Maybe anyone have a question?
I just wanted to translate for Professor Ramon that the answer. Thank you. I can see in the chat. Thank you.
Yes, and second part of answer, that the second experiment is too hard to compare with theoretical values. So Professor Bakuer don't know how to make such compare at the moment, but he work in the next semester on this problem. Thank you.
Thank you, Sergey Alexeyevich, for translating.
And our seminar is
time to finish.
Time to finish.
Yes, yes, yes. Thank you, Ramon.
Yes, so we are grateful to all participants of the seminar for interesting presentation. And maybe there are some participants who would like to share their impressions and feedback. Please, we will be glad to hear. Professor Raymond Delos Santos.
I would like to thank the organizers of this event. Thank you very much for the warm welcome. Can you hear my audio? Is it clear from your end?
Here.
Okay, yes, yes. Thank you very much for accommodating us despite the difficulties. I am very happy and my heart is full of gratitude right now to see you, everyone. It's actually my first time to meet people from Ukraine, also from Serbia, Colombia, Slovakia, right? From last night's conference. So thank you very much for the warm welcome. I'm praying for everyone's safety and despite the difficulty. Thank you very much.
Thank you, and thank you for support. Thank you for useful.
Thank you so much. If it's possible, several words. Really, I also want to thank for all the researchers and a special thanks for the organizers that during this period of war that you are conducting the conference and you conduct it on a very high level. Thank you.
Thank you.
Thank you.
Thank you. It's a really international conference and a really international seminar and very useful reports. We thank you for all participants. Okay. We will.
Maybe Professor Semerikov something.
Say something.
Sergei Alexeyevich, please.
Thank you. I would like to thank all for participation, for a very active participation, not only on this session, but 2 working days. We can see most of presenters as an active listeners and discussants. So we wait for our next events this and next year. We will try to do our best to represent both in event of this conference, next symposiums, etc. So in the level of publishing, after conference, we will inform for the last organizing issues regarding the publishing conference proceedings in journals of physics conference series. We don't allow your attention to these problems before conference, despite the uneven situation in Ukraine. We should to finish this event, report our publishers that all done, all okay, and then the next stage is the proceeding. We await that proceedings volume will be published in the late of June this year. Thank you one more time for your for your hearty attention to our conference. I will be happy to meet you not one, more and more time the next years. Thank you again.
Okay, we have finished. See you next year.
Thank you.
See you next year.
Thank you so much. See you.
Thank you. Bye.
And we will stop recording now.
Stop recording.